Up YouTube, Woo! Mr. King coming at you live from the studio. Here are the questions for the day. Please pause the video now and answer them. Next, just recall, hint for number 3, kinetic energy is energy from moving. So the faster something is, the more energy or the more power it has. Next, here's some announcements. Grades are up to date, and you have your first chemistry quiz on Thursday. The quiz will be on endo versus exothermic, states of matter, and energy. Yep, then we had a little Kahoot for review. And then when you're ready, can you go to Google Classroom, classwork, feel the heat, Gizmo. It looks something like this. You won't be able to finish it today because it's too long, but we'll get to question 8. Okay, so I zoomed out a ton. Zoom in. Make sure you sign in. Okay, here you go. Looks normal now. Remember to sign in, go up here. Okay, then go to slide 2. To begin, select test powders, drag a bottle of sodium acetate from the shelf, set water to 100, powder to 35, and watch what happens to the temp. Okay, so this is a lab we would be doing in person, but since we don't have the chemicals, you'll have to see it virtually. Okay. Okay, I'm gonna press play. Then watch what happens to the temp. Number 1, did the temperature go up or down? Notice also there's no flame or anything here. All we're doing is just mixing the sodium acetate with the water. We're gonna go over how it works later. Number 2, experiment with different powders until you find one that produces the opposite effect. I'm going to try, reset. I'm going to try using potassium chloride. This is what they use to kill inmates on death row. It stops your heart, so I wonder if it will make the water colder. Let's see. Oh, as right, it did. That one is potassium chloride. Okay, number 3. Well, first, when a powder, we have some notes. When a powder dissolves in water, a solution is formed. The powder is the solute and the water is the solvent. So here's my analogy. Let's say you're making chocolate milk. The chocolate is what you're adding, so that would be the solute. The chocolate is a solute, but milk will be the solvent. That's like the base. You're adding the chocolate to the base, you're adding the solute to the solvent. The solution is the chocolate milk itself. When it's all mixed, that's the final product, the solution. And what device we're using is called a calorimeter. That's the device that records temp. Okay. Now we're going to investigate why does the temp change when you're dissolving powder in water. First thing, now you're going to experiment with the sodium acetate, but put the show molecular view on and set the powder to 20. Okay. I'm going to reset it. Boom. Get the sodium acetate. Set it to 20. Okay. Show molecular view and then press play. Now notice, what are the bonds of sodium acetate? What do they look like? What do these bonds, what color are they? That's number 3. And then number 4, what is happening to these bonds? What is happening to the orange bonds? That's number 4 over time. Okay, I'm going to play it one more time. So we're just adding sodium acetate to water. The water molecules are the ones that look like Mickey Mouses. Okay, so you add the sodium acetate powder in, sodium acetate's in the middle, and then what happens to those orange bonds over time? And then 5, what color are those new bonds? What color do you notice is happening to the rest of the sodium acetate? What do the new bonds form? Okay, so that is number 5. All right. In the animation, the purple arrows represent energy that is being absorbed from the water, while the orange arrows show energy that is being released into the solution. Replay the animation, carefully noting the purple arrows. What does the absorbed energy do? So try and figure out, what do the purple arrows do? Let's watch. So purple arrows, what is going on with the purple arrows? What do you think they're doing? Okay. Yep. That would be number 4. That would be number 6. Number 7. Now focus on the orange arrows. What happens every time an orange arrow is released? So now we know what happens to the purple. What do you think happens to the orange one? The orange ones are these big orange arrows that are going outside. I'll give you a hint. You don't need to look at the atoms to see what's happening every time an orange arrow is going out. You don't need to look at the atoms. That's number 7. What do you notice happens every time an orange arrow is released? Yep. And then number 8. When the bonds are broken, energy is blank. That has to do with the orange arrows. And then when new bonds form, that has to do with the purple ones, energy is blank. I'm going to play it one more time. Watch what happens when you see purple and orange arrows. Do you think the energy is released or absorbed when you see purple versus orange? Okay. Might be a little tricky. I'll give you a hint. The answer for 8A and 8B is either released or absorbed. So when the orange arrows go out, is energy being released or absorbed? When the purple arrows go in, is energy being absorbed or released? Once you get done with 1 through 8, you're all good to go. You are ready to move on, and we'll finish the rest of it tomorrow. Thank you so much for staying with me. Bye.